All right. All right, well, like I said, I'm really excited to be here. To me, this is what DevOps is about, coming together in small conference, small teams, and being able to discuss to each other about different ideas, different things that we're working on. Without people collaborating, without people coming together and talk about what they're doing and interchanging ideas across companies, DevOps really wouldn't be what it is. So today I want to talk about our transformation at Capital One that we've done. So Capital One, maybe about 5 years ago, we were still on-premise. We weren't really doing any DevOps. And in a very short amount of time, we've really transformed our organization from traditional monolith applications to microservices, no data centers. And it's been an impressive journey. A lot of things that helped us get to there. We learned at conferences like these, AWS, the reInvent conferences, DockerCon, stuff like that. So just a little bit about me. I'm Daniel Esponda. I work in consumer identity. That's basically all the login that we manage at Capital One. We have something about 100 APIs that we manage throughout 27 different teams. Now, before I get started, I just wanted to get an idea of this group. How many of you guys are using the cloud today? And you can raise your hands. Excellent. That's really awesome. Maybe about 3 years ago would be less than half that amount. And about how many of you guys are using containers in the cloud? All right, it's getting there. So I want to talk about where we were maybe about 3 years ago, right? So, or microservices, there were no microservices. It was a very monolithic application. We just had one huge monolithic API that we had for one huge monolithic API for login, one huge monolithic API for enrollments, and different services like that. And we said, all right, we want to go into microservices. So the teams are like, all right, microservices is just splitting up the API into small APIs and put it in the same Tomcat container, and we'll push it to the cloud, right? Not quite. Now, why did we do this? So if you have worked with AWS, you know that there's T2 instances and there's M4 instances. One of the issues that we ran into using very small boxes with the T2s is that there is you have CPU credits. And unfortunately, you have a hard limit that you can reach account-wide. So if you run out of the CPU credits, your T2 micro, T2 nano instances are going to be limited significantly to about 20 to 10% of their CPU. So we couldn't go with T2 instances. We had to use M4 large instances, which were way more costly. So we couldn't put each API into its own little box. We had to cluster these APIs in one large Tomcat server. Now that has significant drawbacks. There is no isolation of your microservices. All of our APIs had to be deployed at the same time, and our load balancer had a health check that would check every single health of all of our APIs, and if any one of those APIs health check failed, the whole stack would go down. Now that's not good, because now you don't know which was the stack that failed, or anything like that. Another thing was we were also using Chef to orchestrate all these services. Now, I love Chef, and Chef still has certain uses, but it takes a significant amount of time, and it doesn't really get into the whole mutable servers, right? You really want an immutable server that doesn't change. Chef kind of doesn't provide that, as it's running maybe once every 30 minutes, checking that all the configurations are still there, and making changes. Also, to provision a server, it took a significant amount of time, somewhere around 5 to 20 minutes to provision a single server and get it into service through AWS. That meant that auto-scaling was impossible, right? So if our CPU was getting to 70% and we needed to auto-scale, getting a new instance in service would take another 5 to 20 minutes. By the time that was ready, our CPU would already be at 100%. We would start getting 503s from customers, and it wasn't a good experience. Now, what did our deployment process with Chef look like? It was really complex, and it really wasn't a modern deployment process. Now, you can do a modern deployment process with Chef, but there were certain limitations that we had at Capital One that just that wasn't a good environment for it. So basically, we had the dev team, they had to identify which chef cookbooks needed to be promoted to the production environment. Then the release team had to approve them. Now, chef cookbooks also have some dependencies that we were uploading to the S3 repos or the Nexus repos. We also had to get those approved. And then the release team had to approve those. Finally, the development team had to request promotion of their actual APIs to be promoted to the production repositories. The release team would approve those, and then the dev team would come and say, all right, go ahead and start deploying my application. Well, again, like I said, it takes quite a while to load, so now it's about 30 minutes that we have to wait for the instance to come into service, so everyone goes, gets their coffee because it's 3 a.m. in the morning, and everyone's really tired. So 30 minutes later, everyone starts trickling back into the production call, and the instances haven't come into service yet. And that's because we missed a step of promoting one of our chef cookbooks. So now we have to restart the whole process, request a promotion of the chef cookbooks that we missed, restart the instances, another 30 minutes pass by, and we hope and pray that this time the instances come into service. So maybe about 5 hours from beginning to end, everyone's finally done, and we have completed our deployment process. But that's a really long time. It was really complex, and wasn't quite working out for us. Now along comes Docker. Docker was really, well, containers, I should say, really, is what really improved our whole infrastructure. Now, the best thing that Docker provides to me is isolation, as far as isolating your failures, isolating where things are happening, right? First thing that really helped us was you could check the health of a single API. So if one API went down, it didn't mean that your whole stack had to go down. You could also deploy APIs independently. We didn't have to do these deployments where we were deploying 10 APIs at the same time to one Tomcat server. That also finally enabled our auto-scaling, right? These instances were no longer taking 5 to 30 minutes to come into service. They were coming service in less than 30 seconds. So now, if it was 70% CPU, it spikes to 80%. We start two new Docker containers, and they come into service, and now our CPU is back at 60%. So it was a lot quicker to auto-scale. We no longer had to over-provision instances. Before we said, okay, well, we can't handle being at 70%, so let's make sure that we're always at 10% CPU. So we were having to deal with putting 4 times the amount of instances that we actually needed, just in case we had a large traffic spike, or maybe there was some kind of DDoS attack that got through our filters. Another thing is kind of security. Secrets are isolated to that single API. We were no longer sharing chef secrets in the cookbooks between all the different APIs. Another thing that I have realized is that adoption of newer technologies also forces teams to make changes and improve their infrastructure. So by releasing one API at a time, that really lowered our risk significantly, right? Because we were no longer risking the deployment of 10 different APIs every single time we deployed. That also eliminated the validation step. Before, we were having to do a validation that everything worked before we could switch the DNS from the blue stack to the green stack, because we needed to make sure that all 10 APIs were working correctly. Now, since the health check was checking only the health of that single microservice, we could have a health check that checked the full functionality of that API, and the teams didn't have to validate. So now our deployments were even better, as soon as that health check passed, you know that container is ready to take traffic. So then that led us to say, all right, we no longer need to do blue-green deployments. We can now do canary deployments. So if you guys don't know what canary deployments are, it's basically the way we implemented it is, let's say you have 5 containers, and they all have the old version of your API. Well, we're going to bring one new container of the new API. So now you have 1 new, 5 old. Then you'll destroy one of the old ones, bring another one in. So now you'll have 2 new and 3 old, and so on until your whole stack has refreshed into your new version of your product. Now, in case rollback was needed, well, let's take one step back. In case one of those APIs failed, you were okay because no traffic was being routed to that API, and you still had your 5 containers that had your old code in it. But if there was something that was wrong, let's say the health check was passing, but there was something still wrong with your API, you were getting some 500 error somewhere, rollback was really fast. You could just deploy your old version of your code, and again, 30 seconds for deployment, really quick and easy. You're not facing a big incident. Now, we did have some services that we had difficulty putting into Docker containers. And that's when we found out, okay, well, why is it difficult for us to put these services into containers? Well, maybe they were doing too much, right? The health check was not able to test the full functionality of that API, and that told the teams, hey, we're really doing too much in this API. We need to break up the different components of this API and make them into smaller microservices. Or there were some APIs that had too many interdependencies. We couldn't fully check the API because API A had a dependency in API B, and we didn't want to create a health check that depended on 2 different services. So we did some re-architecture work so that there was more of an orchestrating layer on top of those, and these 2 APIs acted independently of each other. So by adopting Docker, we really forced teams to really take a hard look at their infrastructure and say, are we really doing microservices correctly? And that was one of the kind of like so rapidly break up our monoliths into microservices and put them in the cloud that a lot of times it was just done in a rush kind of effort and we didn't really analyze correctly. But by adopting Docker, it really forced these teams to take a look at their architecture, how everything worked, and see if they were doing it correctly. So what does our new production release look like? Well, the app team just requested the Docker image be deployed into production. The release team deploys the Docker image into the Docker cluster using a canary deployment, and usually everything is good to go in 30 seconds. Everyone gets their afternoon coffee. No more 3 a.m. releases, because if something does go wrong, we can roll back to our old stack in less than 30 seconds. There's nothing that's really preventing us, right? Even when we had blue-green, we weren't sure if the new API would be stable for 3 days down the line, so we were having to keep our old stack up for weeks on end, just to make sure that we had something to roll back into, because, again, the deployment process was so complicated. With this deployment process, we don't have to worry about that, because any rollback, it's very, very rapid, 30 seconds. So what were the results? And so the overall summary is that deployments took from 5 hours, we're now 15 minutes. And really, that can be unattended, but there's still, since we've been moving so fast, there's still, some teams still don't have that full confidence of, I can just let my deployment flow without looking at it. Teams are still kind of stuck in their old ways of, I want to see the deployment happening, and I want to make sure that nothing happens wrong. But really, it could be done unattended. If something happens, rollbacks are really easy. We've seen teams really increase the number of deployments they do in QA and production. So before, we were looking at maybe 1 deployment every month, maybe. Now teams are really starting to look into 1 deployment per week, and we really want to get that to, I see some companies doing 6 deployments a day. That's where we should be at, but because of the critical nature that is logging at Capital One, we can't have any services go down for any amount of time. So we really need to make sure that everything's there and everything's fully ready to go. We also found some performance issues with certain APIs that were hidden, because when we were deploying 6 containers into 1 Tomcat container, if the Tomcat container was acting slow, we weren't really noticing. We just said, oh, this is the fault of the EC2 instance. Let's just use a bigger EC2 instance. Let's use an M4 2x large or 8x large, whatever fits. Doesn't matter. But we found out that there were certain APIs that were slower than others. And we were able to find that through monitoring individual container instances. And then we found out, oh, you know what? There's a memory leak here. Or we didn't configure the number of threads correctly for this API. And that really sped up the performance of some of these applications. And finally, incidents that could have been severe were not as severe anymore. So lately, I don't know if you guys have tried messing with M5 or C5 instances in AWS, but they had some issue where randomly they would lose all connectivity without warning. Now, if we had still been in our Chef deployment or all kind of deployment process, network would have been gone, new instances would have come into service, but it would have taken 30 minutes for those instances to come into service, and we would have had a large severity incident at Capital One. Logging would have been down, no one would be able to look at their accounts or transfer money or anything like that. But because we had Docker, new instance came up, 30 seconds got deployed, we saw a minimum downtime of 30 seconds where customers were not able to access their accounts, and it was just a huge improvement. So incidents that could have been very large were minimized. So I just want to close it out. Like I said, this is really what DevOps is, communicating, networking with different people. Please feel free to reach out to me or talk to me here. My email's on the screen, daniel@esponda.capitalone.com. And finally, if you want to be part of this process and get those 15 minutes down to 6 deployments a day, we're hiring. My team is hiring. Capital One is hiring. Please feel free to reach out to me, and we can see where you guys fit. Thank you, guys.